All right, so today we're going to be going through a couple of things today, which is like HSRP, Ether channel, NAT, and some other things as well. Like, so, for example, I found out that you could, I'm a bit shocked though, because it should be saved in my Mega Lab, that you can have DHCP, and with DHCP you can have an access on the switch as an access port rather than a trunk, and you can then use that as a means of getting DHCP addresses inside of your PC. I thought it was very strange, to be honest, but apparently you can, and it works in Packet Tracer. So how does that work as an as an example? Ugh, losing my voice already. It's only been about 5 minutes. So basically what you do is you have some switches like this, right? So you have this one switch. Now let's say you have a 2960, or 2901, even better still, 2960 for a switch. Okay, so now what I do is I create a crossover cable between a 2960 on G00, which is our gigabit interface, and then G01, right? So at the moment it's not configured, which is why it's not working, but that's fine. Then what I do is I go down to our end devices, make some PCs down here. 3, 4 like that. So let's say I have that many. Now, let's say that these are all on VLAN 10. Yeah, so I'm going to pick a VLAN for this in a minute. Just give me a second to get this all sorted. 3 and 4. Okay, then I'll fast forward. Okay, so that's all good. So this is interface range, right? Because we have interfaces from 1 till 5. So let's go do our en conft, let's do a host name, and let's call this, I don't know, we'll call it directors. Let's call it that. Directors office, actually. Like this, yeah? Now if I go and do a int range, fa0/1 through 4, now I'll do a swimo ac VLAN 10. Whoa! No, ac, swimo ac, which means switch mode access. Then I'll do a switch mode access, and let's say VLAN 10. Switch mode. So this is switch mode, right? Switch port. Let me double check this. Is this switch port? Switch port, yeah. Switch port access VLAN 10, right? So that's swimo ac VLAN 10. So I'm using swi ac VLAN 10. Sorry. So I'm using shorthand here. And now if I go do an end, I'll do a show VLAN, right? You'll see in here I've got VLAN 10 configured. So through 1 through 4. Now 1 through 4 like this basically means that VLAN 10 is assigned, right? But this is an untagged version of VLAN 10. So this is all untagged. Because tagging usually involves the trunk. So here's what we're going to do. We're going to go to G01. Okay, so we're going to go conft int G0/1. Now from here, what we're going to do is something very unorthodox. Normally we do a trunk, right? So we have our sub interfaces, right, which is like our intg 0/0.10 to indicate that it's for VLAN 10 on what's called router on a stick. But at the moment we don't have that, right? Because this basically is going to be, and in fact the switch is probably not the best place. Let's go to the router. Let's do no en, we'll do a host name. I'll call this directors router, and I'll show you what I mean in a minute. Oh, because I haven't got conft, that's why. Configure terminal. Host name, and we'll call this directors. Like this, right? That's fine as well. I don't mind necessarily that, but let's make it a bit more. There we go. Directors office router. Okay, and then we'll do a, what did I call the interface which goes down towards the switch? 00. Okay, we'll do a 00. int G00. And we'll put an IP address, let's call it, I don't know, 10.10.10.10.1. Yeah? Now let's call it 255.255.255.0. 255.0. Ah, and I see my mistake there, put a 4 there, that shouldn't be there. There we go. Okay, let's have a look. What's going wrong here? IP address. Ah, too many 255s. There we go. 255. There we go. No. 255, 255, 255, 0. There we go. There we go. Now do the no shut. Let's end that. Conf T. And then we'll go to IP DHCP pool. And we'll call this directors pool. Okay. We'll call the DNS server the same as what we have here, which is 10.10.10.1. We'll call it default router 10.10.10.1. Okay, and that's good. I don't think. Oh, we need the pool. Right, yeah. Our network, we'll call it as 10.10.10.2. Yeah, to 255. Why we want that? Because 255.255.255.0 is going to be our network pool that we're going to allocate towards the PCs at the bottom once we configure the access port on the switch going towards the router. This is what I found very interesting today. So that's all good. Let's end that. Let's go to show run. And let's see what we have here. So we have our pool, which is good. And we've got our interface up, which is good. Now, the one thing we're missing is the IP DHCP excluded address. The reason why that's missing is because I forgot to add it there. But what we can do is we can configure it. So if I got IP DHCP excluded address 10.10.10.1, now the router IP address doesn't get assigned to any of those PCs, which is exactly what we want. So now if I end this and do a copy run start, right? Copy run start, and I think I've made one error here, which is not, no I haven't, it's fine. So that's all up, and you see this interface here, right, which is G01. Now let's go to, where are we, G01, good. Now what we're going to do is this. This is something which I learned today. Switch port, access, VLAN 10. Switch port, mode, access. End it, copy, run start. Okay, now we're going to see whether or not we have IP addresses. Oh, here's another thing, because that's in, that's doing STP right now. That's why it's orange. You see that orange? It's STP. But we don't need it going through STP because it's in an access port and not a trunk. It's not connected to any other switches which form part of the root bridge, because we haven't made this switch the root bridge. So all we have to do in that case is do a conf T, switch port. Yep, so we're going to go switch port. Let's see, switch port. All right, let's think about this for a second. We need to do an INT. There we go. INT G01 G0/1 switch port, not port security, but port security is actually quite a good one for this. So you know what? We'll do port security. We'll do MAC address sticky. MAC address. Whoa! Why won't it let me do MAC address? Oh yeah, well, okay. MAC address. We'll do a sticky. We'll do a violation, which is going to be the shutdown. So switch port security violation shutdown. Okay, so shut down the port in the event that there's more than one IP address. But in order to do that, we have to say maximum. So let's do a maximum of 1. Maximum. Not violation, we'll do maximum. Maximum. So that's the maximum number of MAC addresses it can store, which is 1. Now let's exit out of that because that's all good. And we'll do a copy run start. Copy run start. Okay, that's it. That's good. So now, when we go back to our PCs, and let's go down to our desktop, we'll go to our command prompt, and we'll do an IP config. Right, we've got no IP addresses on here. So what we'll do is we'll do a release, just clear it. Port is not using IP, not using DHCP. Okay, that's good. Well, then renew it then. Okay, and then we'll wait for the IP DHCP, and boom, there we go. We have our IP addressing straight in. I was shocked when I saw that. I was like, what is this? What is this? I was like, whoa, dude, like that is some next level stuff. Because I didn't think you could do that with an access port, I'll be honest. Right, I'll be honest. And when we do port security on this, which I have done, and I said I was going to do port fast, so I'll do port fast for keepsake. INTG0/1, INTG0/1, and we'll do switch port security. No, switch port. No, it's not that. It's spanning tree. It's spanning tree. So I need to go one out. There we go. Spanning tree port fast. There we go. Default. And this is supposed to say stuff about access port, but because I've already configured it as an access port, it's fine. And that copy run start. Show spanning tree. And that looks good. 2 seconds, 20 seconds, yeah, that looks good. Although that should be in rapid spanning tree mode because it's on port fast. So, store spanning tree detail, I think it is. Point to point VLAN, yeah. There should be one more command here, which is it summary? Let me check. There we go, summary. But it should say, there we go, port fast is enabled. And we're in PVST mode, which means that we're in per VLAN spanning tree, which is good. All right, that's good. So that's that part sorted, basically, for our lab. And then we need to connect that back into our routing systems. So we should ideally have another system here. So we need, I'm going to go for, let's go for a fiber optic, shall we? And it's going to tell us to turn it off, which we will do. Put this over here. Let's put the SMD in, which is supposed to be a gigabit. Which is supposed to be a gigabit. There we go. All right, so we've got fiber optics down there. We'll turn this off. We'll put some fiber in here as well. And then Cisco packet tracer is a little bit funny with fibers, I find. You've got to do like a shut and then no shut again to get it working. And sometimes it doesn't actually work. But the one thing that I found that does work is having the simplex version instead of the multimode fiber. And then I put that in there, and it will, yeah, there you go, see? So what I'm going to do is I'm going to, oh, right, it says it's going to be powered on, fine, put it in, is it powered on? There we go, CLI. And we'll speed that up to do the decompression, and we're good straight away. I didn't expect that. Normally we do a shut and no shut, but in this case we're good straight away, so that's fine. And we have a couple of situations here. So, here's the thing. I'm wondering whether or not I should have, right, because this is error 51. So if I do a NAT between these two routers, now I could put them over with the protocol. So one of the labs in Cisco was one that you can have NAT, you know, you have the IP NAT inside, which is going to be on this side, and our IP NAT outside is going to be here on our IP addressing. Yeah. So what I'm going to do is I'm going to do IP NAT inside for what interface is this? Because I forgot. Interface is this? Is this G0? G00, right? Okay. So let's make it simple. Let's make it simple. En, we'll do en conf t, we'll do int G00, we'll do an IP NAT inside, yeah? And we'll call that an inside interface. Yeah, we'll make it easy. And then we'll make our outside interface. Our outside interface is 030. Okay. G03/0, and we'll call this IP NAT outside. Right? Because that's our interfaces. It's going to be inside and outside. Now here's the interesting part. You know, do we make it a pool or not? And I've got to remember how to do this, because the one thing that's interesting here for me is whether or not I need to have NAT configured on both sides of the link. Now in theory I do, you know, because it's NAT, but I'm wondering, do I need, let's see, IP NAT config. Normally you would have like an ACL, but I usually get a little bit flustered with these because I'm trying to always figure out, you know, if I'm doing this, do I need NAT on both sides? Because there's something called overload as well, which does port address translation. That's where things get tricky. So let's do a normal example here. So I've got one which is like 20 and 19. And what I'm going to do is I'm going to restrict access to one of these. And I'm trying to think, where do I want to restrict access? Here's an interesting thing about IP access lists. Where do you want to restrict access? So I've got 10 on this side, and I've got another network on this side. So did I do, so the thing that I wanted to know here is, did I do sub-interfaces or did I not? I did not. I did not actually make them. So what I could do is set some sub-interfaces. So if I do it, yeah, let's do a DHCP pool here. So conf t, and then we'll do int. What is this? 01. Okay. 0/1. G0/1. And I'm going to do IP address. I don't know. We'll call it 192.168. 90.1 255.255 dot should I call it 0? Yeah, let's call it 0, make it simple. No, that's not right. You said sub interfaces, didn't I? I didn't say configure it there. So we actually need to do something a bit more cunning. Now let's call this VLAN, I don't know, 60. There you go, sub interfaces. So .1q encapsulation .1q 60, and then we'll do IP at 192.168. Oh, I said 90 on here. We'll call it 60 actually. 60.1 255.255.0. No shut. And let's go back to the main interface, which is that one. And I'm gonna do no shut. Okay, that's good. And then we'll do an exit out of here. IP DHCP pool. We'll call this management pool. Let's see, DNS is going to be 192.168.168.60.1, and we'll call the default server, default router 192.168.60.1. All right, cool. And our pool is our network, sorry, is going to be 192.168.60.2, and same as before, 0 end, and we'll do a copy run start. Now the difference in this configuration to the other one is that this is going to be on sub interfaces. Now with sub-interfaces, I could actually put down more than one VLAN, right? So in the other configuration down here, we used VTP to have all the VLANs, right? Because we're going to use things like Ether channel and hot standby redundancy protocol, where we're going to then use VRRP, which is virtual root redundancy protocol, to basically have a unified VIP, which is called a virtual IP address. So that way, in the event of a failure, we can switch back. A little bit tricky to do on this system because of the different subnets in the sub-interface. But the idea is that we switch back and forth. So that way, in the event of a failure in the ISP side, we don't lose internet connection, basically. Now, it's a bit stranger if we go with default information originate, because actually we could do that here. I could do a static link down here to here, and then do default information originate, push it all up through OSPF. I might give that a try. Yes, so in this configuration, what we're going to do is a switchport mode trunk on our interface here, which is FA01. So I'm going to do en hostname. I'll call this management. Conf T hostname management, and then we're going to use int g0 something. What is this? Oh, sorry, FA01. FA01. FA0/1. Okay, and we're going to do a SWI mode true, which means switchport mode trunk, because we're doing .1q encapsulation. So now what we'll do is we'll end that, we'll do a show interface trunk, and what you'll see is we have native VLAN, which is 1, and we have all the VLANs allowed to go through FA01, right, in the trunking encapsulation of .1q. So at that point, as we're going through STP, we should be able to get IP addresses directly. So if I go DHCP, oh, no, we won't. Do you know why? Do you know why we won't? Have a guess. Have a guess. Let's go back here. Let's do a show VLAN. Do you see a problem here? We don't have VLAN 60, that's right. So conf T, and what we're going to do is we're going to do a interface range. And this is from 2 to 5. FA0/1 through 5. And we're going to do a switchport access VLAN 60. And that, copy, run, start. Okay, and we should have DHCP come through now. And there we go, DHCP. Right, so I'm going to configure, or at least I'm going to attempt to configure NAT. Now, I have to think how NAT is going to work here, because NAT can be done in two ways. Like I said, it can be done through port address translation, which is the overload feature. There's redirection, which is like port 80, static NAT, and then there's dynamic NAT. So NAT in itself is not difficult. NAT in itself is actually pretty easy. The bit which is quite difficult is actually doing the things like dynamic NAT and stuff like that. Because basically, normally in the examples, they give you a server, and then you go from there. So maybe having NAT on this side is probably not a good idea. Over here is okay. So I've said NAT inside local on here, which means that the inside interface is local. The difficulty here is now that the outside of the interface is going to be this one here, and that is G030. So what did I configure on here? Let's go show run. So I've configured NAT statically for our server. So our server is 29, right? So we should have an IP address. Yeah, here we go, which is inside NAT outside, inside NAT inside. Okay, that's fine. So we've got static NAT here. And we need to figure out how to make this reachable on the rest of the network. So I suppose what I could do, if I'm doing outside NAT static on there, I suppose I could do overload in this direction. So I think what I'll do is I'm going to be a bit sneaky. I think what I'm going to do is I'm going to use... What's that a door? Right, I'm going to do IP NAT source list 1 interfaces overload. IP NAT inside with a permission. Seems weird. Alright, let me check. See, show run 10001. Okay, so what if I do conft access list 1. So this is a non-named access list, but this is a numbered access list. Okay, what do we need to do? So we have to say permit any host which is 10001. That's our host, but we want our network. And I think I want the wildcard, don't I? So 000.255. Put that in there, so it's permitted. Everything else is denied implicitly. And then what if I said IP NAT inside source list 1. This is going to be on our. This is going to be applied on our inside interface. What is our inside interface? G0 G0/0. Oh, interface. Okay, interface G00 overload and copy run start. Okay, so we've configured port address translation, whereby it's now a single public IP address on the outside. So this was the inside. So if I go and do a show run, right, we have an inside and an outside, yes? So inside is where we are. The outside is going to be on this interface. 30, yeah? So I'm going to look for 30, and I've already got IP NAT outside. So what I'm going to do is I'm going to copy that. Conft, put that there. And then I'll do a external IP address. In other words, non-RFC 1918, because RFC 1918 is private, which is on the inside. So what have we configured? We've configured the IPNAT inside local. We are now configuring the global IP address to go out to the outside. So we're walking, yeah, we're going from the inside to the outside. Literally. Literally. So we're multiplexing all those IP addresses together to create, 10, 0, what do we have? So we had 10, 10, 10, 10, 10, 10, 10, 1, 10, 10, 10, 2, 10, 10, 10, 3, 10, 10, 10, 4, 10, 10, 10, 5. So we get all those applications which is being used. So for example, Skype, Teams, Slack, which all runs on these different ports. And then we're going to run that into our network over something like what they have here is 2020. We're going to use something like this, right? I'll show you. IP address 20, 20, 21, and let's call it 255.25.25. We're going to use 252. We're not going to waste IP addresses on that interface. Then we'll do that, no shut, and we should be fine. End that, copy, run, start. Okay, we're going to do a show IP in brief. So I want to check that I've assigned it properly. I have. It's up. Seems good. All right, that part is good. Now we've got to do something on the other side to get that working, which is down here. So considering it's a 252, we need the same IP address for a start. So let's get that IP address, right? Because a 252, what's the meaning of that? It has an increment of 4. Why? Because it's a /30 mask. So we need to go en conft int 030. Okay. int d03/0. And we're going to put the IP address of 2020-22. 255.25.25.252. No shut that. End it. And then we're going to do a copy, run, start. Okay, we're going to do a show run. Okay, and what have we got? So we've got our IP address there, which is fine. We don't have any method yet to communicate between the two subnets. Now, here's one thing that we could do. We could do a default information originate, but on the basis that we have a static root. Yeah? So what does that mean? Well, we could fire everything out to the static root. So in our case, that would actually be here. So why don't we do a conft, we'll do a IP static root. Now what I could do here, why is this, let's see, why is this not IPSSH? Is it IP root static? No. Static IP root, what is that? Static IP route, IP root, okay. So IP root, and I think it's a destination prefix, right? So where are we going? Where are we going? Right, so we are going from here to there, actually. This is 252, isn't it? So we need to think of 20, 20, 20, 0. Prefix mask is going to be 255, 255, 255, 252. Router's forwarding address is going to be 2. And that's it. That should be it. So now we have a means for the network No, that's not right, is it? Because it's directly connected. Hmm. Hmm. It's directly. I mean, it would work in terms of routing that traffic. No, it wouldn't. It wouldn't work. No, that's not right at all. That's not right at all. Because it would have to be a default route out. So actually, we should do a default route. We should do a default route. And then do 000. I don't like that. I don't like that because it's all OSPF. Let's see. Hang on a second. So if I want to push all this up, we have our IP addressing here. This is all fine. And we want to push it out. So if we were to push it out, where would it go? 030. Yeah. So it'll be IP route. And then we're going to do a default route. And then oh, sorry, 0. And then what we could do is we could use the interface, which is gigabit Ethernet 0/30, and default route without gateway. If not, point-to-point interface may impact performance. Default route without a gateway. Forwarding router's address. So what if I just said 20? Because that's the forwarding router, isn't it? That's the router which is next. The next hop is what I like to call it. So what if I just said that? Okay, now you're happy? Okay, fine. Show IP route. So we're forwarding that out. And we have a static route which is directly connected, which is correct, to the next hop. See, this is what I like about static routes, because I like to think of it as the destination, but the destination of the next hop and then the hop after. And it serves me well that way. It works much better. So that means we don't even need, at that point, we don't actually need to say what's going on here. So this could just be a static route, literally. And it would work for cross communications. So all I need to do is really just IP route, and then just do it the other side. G0, so it would just be static route like this, right? Because we've got multiple IP addressing going on. So to have one or the other kind of doesn't make sense. Better to send everything. That's 300. So 030 gigabit. Come on, gigabit. Gigabit. IP route. Here we go. 0. Gigabit Ethernet 0/30. And then put that on there. Call it 1. And copy run start. All right. Does that mean we can now see our ranges? Good question. So let's have a look. So where are we at the moment? So we're at okay, let's try this. 10.112. Now what I'm gonna do is I'm gonna put it in simulation mode. Because I don't actually know if this works. So what I'm gonna do is, if I'm not certain that it's gonna work, I'll put it in simulation mode. And I'll have a look for one of these. So I don't know, let's call it this one. Okay, we're at 62. So ping, let's do that, 10.2, and notice the packet. Let's have a look, see what's going on here. Does it actually care? Okay, we're up. That's good. Good sign so far. We're not getting rejected. That's good so far. Oh, it's coming back down again. Should have gone through the network. Okay. Ah. So it's not in the Ceph, so we're not in the routing table. Interesting. The Ceph table does not have an entry for the destination IP address. So Cisco Express Forwarding, which is called the Ceph, does not have an entry for the destination IP address, right? Which is interesting because we have a default static route going towards that network, right? To hand off to the next router, which does have it inside of its routing table, right? So that's the interesting part. So let's see what happens. Fires it off, fires it back, and says okay. So that means if I look, let's see, let's go back down to the switch. Okay, and he doesn't like it. Okay, fine. So that means I don't think that's gone through. I'm going to put it in real time. Request timed out. There you go, request timed out. So it's not found it. Request timed out. Request timed out. Request timed out. Okay, so it's not found it. It's... Oh, we actually have found it. That's interesting. Okay, it took its time, but it did actually go there. So it did actually work. That's interesting. So what? Why did it fail 4 times? It shouldn't have failed 4 times then. Okay. Yep. Oh, it got forwarded. That's weird. So it didn't actually... Okay. Yeah, so it got forwarded. Hence. Okay. So that makes sense. So everything got forwarded back. So which is what it should have done, to be fair. Alright, so that works. Good. Good. Let's do a show run. Oh, that's good. IP access list is permitting. That's fine. 10.0.0, so that's good. However, if I do it the other way, that should fail. Because... Oh, that's not supposed to be there either. Let's get rid of that. Conf T. Put it down here as a no. End that. Copy run start. And that should fail if I was to go to the other side because we've got that IP access list there. Right, so the one which is closest to the source is the standard, right? So the standard one is closest to the source, which we have, and the extended one is closest to the destination, actually. Doesn't make any sense. Hang on a second, I've made an error here. Standard versus extended. And one is closer to the source, one is closer to the destination. I'm trying to think which one it is. And this is why it's revision. So standard is closer to the destination. So in my case, the actual access list is, well, it's kind of wrong. The access list should be down here. And then the extended should be placed closer to the source. Extended is close to the, so E, source, standard, destination. Yeah. All right. So, but even then, that's kind of probably not going to work, is it? Let me check. 65, yeah. So 65 should be blocked. So if I was to do a ping on 192.168.60.5, it shouldn't work. It should just be like, yeah, I'm not doing that. Because of that access list. There we go. Timed out. Oh, it says timed out. It should be destination unreachable. Okay. Timed out. Timed out. And we got a reply. We actually got a reply. That's interesting. Which is interesting. Show run. Right, we got that permission of the... Ah, you know why? You know why? Because it's not been assigned to any of the interfaces, that's why. So if I wanted that to actually block, that has to be assigned to the interface. So what I've got to do is got to do a conf t and then do int on the incoming interface, which will be this one, right? Because that's the incoming interface. So if I was to do that and then say access group, it should be like access group, channel group. It should be access group. Is it IP access group? It is, okay. And then say what it is, which will be 1 in this case, and then the direction, which will be in. Now if I did an end, copy run start, and it should block, because it's closest to the destination. That should be blocking. Oh, interesting. Oh, really? You're going to do a timeout? So you're going to get it? How interesting. Despite it being closest to the destination. So you time out. Yeah, but it shouldn't go through anyway. It should be blocked by the IP access list. On the outside net, on the outside interface. But this is going to be timed out. This is extraordinary. Okay, it times out. So simulation mode. I'm going to simulation mode. I'm going to see what's going on here because I'm quite interested to see what exactly is going on here. So 10.5. Let's go through. And it goes past. Okay. Goes into the system, finds it, comes back up, and it should be blocked. Yeah, there we go. Blocked. Which I think... There you go, IP access list. So it does get blocked, but it gets blocked on this side of the link. So it doesn't come back as destination unreachable, it just says it times out. Interesting stuff. All right. Okay, so we have that. Now we need to check our NAT. How do we want to do that? Our web server. Web server doing NAT on the overload. So they're going to be translated over. Okay, so all of these will be translated, right? Because this is my revision as well. So I'm looking at this. And if I do a show run, all of these IP addresses are going to be translated into that 2021 on the LAN side of things. Because they're multiplexed. and then they will be going towards the ISP, which is that router at the moment. And then they need to go through to, for example, this web server. So I'll give you an example of what I mean by this. So here's a step-by-step guide, right? So what's happening here is not very clear, actually. It's a little bit naughty, but basically you've got like all the. So this is what we need to take out from here, right? So it's multiplexed, many to one, single because we're doing port address translation, right? Which means that every port on the LAN side of things, which is 1.0 in this case, will be translated back to the public IP address of the router. So the public IP address of the router is 20.20.21. Yeah, because the inside of the network is 111. Web server is on 110. So that's going to be doing the port address translation. Now the static address translation will be where the server is on 10. Yeah. And basically it's going to translate it back to an IP address, which is this on 80. In fact, we could do that. So what we could do is we could hang we could hang a server on the switch. In fact, we could really easily do that, actually. En show run. And what we need to do is actually exclude an IP address. So we need to go back to our DHCP excluded. Oh, this is a switch. Okay, go back here. Do a show run. And we need to find our DHCP pool, which is here. So we'll do a conft interface. One second. Oh, it's for the DHCP. Right, okay, yeah. Okay, fine. Where's DHCP? DHCP is here. IP DHCP pool excludes. Yeah, here we go. We'll go here. What we'll do is we'll do a we'll call this 254. Yeah, inside the pool. So our IP address has now become, right, we end that, show run, go down, and we'll now have a couple of IP addresses which are excluded in the pool. Or we should do. We've got 1 and 254. Right, so what we'll do is we'll do a copy run start. And what we'll do is we'll create the server, right, which is going to be here. And we'll put this on a trunk line. Down here, back here. And we'll make it static. So we'll say 10.10.10.254, and we'll use 255.255.0 for our thing. We'll use this as 10.10.10.1, and that should be now fine. Let's go back to services, and we'll do HTTP. We'll enable the HTTP. I'm not sure if this is actually enabled or not. And then what we'll do is we'll exit out of that. We are on the same network here. So what I could do is I could see if I can go, for example, to the web browser and just see if it's actually on. So we'll go 10.10.10.254. Not getting anything back, which is interesting. We should be able to see something on that. Weird. We are on the same subnet, so I'm surprised it's not giving us anything. Maybe it's, I don't know if it's enabled or not. No? Are we on? Are we off? I don't know. Okay, I'm going to toggle that there. That was on there last time. When I did this last time, that's what it was. Okay. I'm not sure why exactly we're not seeing this. This is completely fine. It does request timeout for whatever reason. I have no idea why. I don't know if we can see that in here. We don't even see what's going on. It doesn't go through the switch at all. What? Encapsulated DTP. We're not using dynamic trunking protocol. Should be disabled anyway. Okay, I don't know what's going on with that, but okay. Right, let me think. So what have we done? We've done access this, we've done that. Done overload. No, we haven't done overload. Okay, we're doing the static NAT. Okay, cool. Okay, no problem. So what we're going to do is we're going to do a NAT translation. So we're going to do IP NAT, I think it is. Let me just double check. Is it IP NAT? Yeah, IP NAT. Inside source static inside local IP address, which is 10.10.10.254, inside global IP address, which is here, 20.1. There should be a little bit more to this, and that's what it is. Okay, let's go back and double check that, but it should be right. So if I go back, we've got port 80. I forgot about port 80. I forgot about port 80. Static TCP. Okay. Okay, I've actually made a mistake there. Do a no. Go back. Source static TCP, and here's 80, and then we'll do 80. The other one would have worked as well. The actual inside source static, that would have actually worked really well for HTTPS. But we're not doing that. We're doing TCP and 8080 for the web server. So that should be fine. Even if we don't receive anything, the actual configuration is fine. Copy, run, start. Okay, cool. Nice. Okay. So our web server's up intact. We've done our NAT on this. We could have a couple of web servers up here, which is going to be doing NAT again. And we're going to go through that as well in a bit. This stream is only going to be up until about 6:30 because I've got to do some other stuff. But anyway, how are we doing? Are we doing all right? Everybody following along? Don't say anything in the chat, so there's probably nobody watching this. But yeah, does the explanations actually help there? Because what I'm thinking is, you know, we've got our IP addressing in, we've got stuff in now. Now all we've got to do is literally just get this sorted in terms of the areas, right? Because we've got P2P and we've got stuff of that nature. So that's pretty good at the moment. We'll do some access lists as well, I think, because we need to do a little bit more on the access list stuff. And then I'm going to do some HSRP a little bit later on. But my main focus at the moment is just to do access lists and NAT and get that all sorted out for this session. That's going to be the main focus because the exam which I'm sitting requires this particular focus as well as OSPF. I'm just going to go for a quick toilet break and I'll be back in about 2 minutes. Okay. Let's get the phone as well while we're at it. Okay, so we're back, and my back is hurting me as well. Did a bit of gym today, and wow, it's actually giving me a little bit of a knot up in my trap, which is not ideal. Anyway, we're an hour in. We've done a little bit today, so we've done some ACLs, we've done some NAT, I mean, particularly on the overload side of things, and we've done static NAT as well. So the only one left for us to really do is dynamic NAT, to be honest. So let's have a look at how we could actually implement that in our network. So we've done port redirection, we've done static NAT port translation as well. We've actually done static NAT as well, to be fair, because that last command that I ran was static NAT. You know, we've done our IP NAT outside and inside, and this was a static NAT IP address that I talked about, which wasn't the redirection of the port, but that was the redirection of the entire service. In fact, I could actually, for the entire, do I want, no, I don't need to. I've already got pack configured. I don't think I need to. So that should be fine as well. Yeah, so let's have a look. Where is our dynamic NAT? IP NAT statistics, yes, but that's only within an active session, so we can't use that just now. And then clear, I think it was NAT translations, wasn't it? As the other one. Store static, we've done that, we've done that. So now we need dynamic NAT address translation, which works with the pools. Dynamic NAT. And we've got an access list. We go in with the access list to permit certain things. Define which internal IP addresses need translation with the NAT list. So if we... Oh, hello. What happened here? I thought I had one here. Let's go dynamic lat for now. Let's see what we've got. Because I'm studying this as well, remember? Done that, done that. We need to configure an ACL which will include all of the inside source addresses that need to be translated. Okay. So if we need to translate them, we've got port address translation on this side, right? Okay. I'm trying to think where this would be appropriate. And right now I think it'll be up here. So if I add like another couple of servers up here, I don't know, let's go 3, you know, call this a web, we'll call this a web farm 6, for example. And we'll do some, I don't know, 1 here, here. One here. No, like a data center. That's a DC network. We'll call this data center. Yep, and then we'll do a copy run start for that. Okay, so we've done that. We're going to fast forward. Oh, I'm in simulation. I don't want to be in simulation. Fast forward again. All right, we're good. And we've got 2 routers on this side. And let's just check how I configure this for any IP addressing. Oh, I have, great. I've got outside and I've got a static one at the moment. Don't really need to do the static, to be honest. So I'm going to take that out. We don't need that. I want to do dynamic. So we'll do a conf t. And we will do a no on this. Okay, that's good. And then we need to think about our IP addressing. As one network, we want our actual routers to, our servers to be on. So what do our servers need to be on? Good question. So right now they're statically assigned to 0024240 on 10.1.10.0.0.1. 10.0.0.1 should be on this side of the translation, shouldn't it? So it should be here, which is good. So we need an access list. So we could use a named access list in this case, because a named access list is something which can also be used. So what we could do is we could say IP access list. So what do we have? So we've got source and destination, right? I talked about source and destination, which was standard. And then we have, this one is more a standard one. Sorry, not a standard one, but it's going to be more of an access list, which is extended, even. So let's do an extended access list. We'll call it a named one, which is going to be DCNet. We'll call it DCNet. All right, and that's our extended one. The extended ones also have, from 1 to 199, 100 to 199. Generally, there's also like 1,000 one a little bit later on, which you can use. But generally speaking, you don't need to do all that. So we're going to use like, what we're going to say, IP, access list, isn't it, this one? Oh, all right, permit and deny. So let's have a look at our example, because this is new for me as well. So we've got a permission of what we want. Just a standard access list here. So what we want to do, so we want to permit it, don't we? Wait, what's going on here? So if I say permit, what are we going to say here? Permit TCP source address. We've got source address, so it's going to be 10.0.0.0. That's our network. With our wildcard mask of 0. What was our wildcard mask? Is this what I think it is, or is this? Yeah. Okay. 0.0.0.255, and we're going to make it our destination network. Oh, this is. Hang on a sec. Let me check. Let me think. Or could we just end it like that? I don't think we can, but an extended. So that's basically source and destination. So destination is going to be oh well, no, this will be any. That's what that will be. Equal to the port number. Oh, we can say equal to the port number of 80. Or www. Yeah. Because that would be where it is. So we can permit any traffic going in there. Now, of course, there's going to be a implicit deny on anything which isn't that particular web traffic. But at the end of the day, that's kind of what we want because it's closer to the destination. The destination is the actual web service. So my thinking there is, well, because it's closer to the web servers, I can actually enact dynamic port address translation for the servers, so that way anything that wants to reach those servers has to go through the web ACL, which is our web firewall filter. That's the thinking there. You know, or even I could do like a DNS as well. Okay, let's have a look at this. So we've got that there, which is good. So the next thing we need to do is we need to say, well, source address translation, don't we? So we're going to go and say, well, you know, what's our IPNAT pool? Well, our IPNAT pool is pretty much that there. So we're going to say in our Mega Lab. So IPNAT, we are in the ACLs. We need to go one above, so we'll say IPNAT pool, DCNet NAT pool, start IP address. So this could be anything, couldn't it, really? Let's see, do we have any which is worth doing? Okay, so they've said, you know, 255.255.2550. Now that is interesting because we are not on 10252, so that's interesting. That is interesting. So I'm wondering, do we need to say, full configuration 1, 2, 3, but what's the, okay. All right, this is what I'm going to do. I'm going to make my pool. Now the pool is on 155. But it needs to link back to the IP address. Remember that IP address that we talked about on the static? So on here, I actually need to change the IP address in. I've got a 240. That's all right then. Oh, that's all right. I can go, what's that? It's a 4, so it's 19. So we've got 192, which is 2. 3 is going to be 224. 4 is 240. And why is that? 128, 64, 32, 16. So 16 IP addresses I can have on this. That's 240. So I think I can get away with that. I think I can get away with that. So if I make the pool in that range, right? Because what is our actual IP address for this? It's 29. 32, is that right? Am I reading this wrong? 240. 240, I think that's correct. What will that be? It's 4, so it should be a 28 range. 16. Yeah, 4 bits on. 240, yeah, 16. Okay. So I've used a really weird range for this, to be honest. I've gone from 229, which is wrong. That actually should be somewhere closer to 17. don't know why I've said 29 there. That's weird. Anyway, let me fix that. That should be on 17. So let's park this for now. And I'm going to say this. No IP adder. No IP adder. IP adder 190. Sorry, 1 second. Let me just go back up for a second. And make this 17. So dot 17. Now do the 255.252.5.240. Right, now end that. Now go back to conf t. Now do the NAT address pool translation. And now I've got my start IP address, which is going to be 18. So 18 through to 31. Yeah? Because 17 we already have. It's already been defined to the IP address. So all I need is this to go to 31. Why is that wrong? What's the syntax? Ah, okay, fine. So what I want is this, and then I want my net mask to be 255.255.255.255.240, because it needs to be on the same network mask and the same subnet in order for the translation to take place and be accessible via that 17 interface. This is why I started the actual network at 18 and not 17. 17 is reserved for the IP address of the interface on this router. Right? Now I'm going to do a exit out of that. I'm going to do a copy, run, start. Copy, run, and config, start configuration. Like so. All right. Now our NAT is actually in place for dynamic base configuration, which is good. So the only question is, how do I get this now to translate from the IP addresses? Because this doesn't actually have one. So we've got static on here. So what I could do is, why don't I take this, because you already have the IP address for this. I'm going to nick this and put this as statics on here. Let's say 241, 5525250. Get rid of that. There we go. 10.0.0.1, which is all good. Of course, 42. 42. 52525.0, and we'll just do 10.0.0.10.0.0.1, 42, 43. Is set. Put this down here. 25525.0. Bring this back down. 10.0.0.0.1. All right, that's sweet. And then we're going to use 4 down here as well, because that's fine. And we want 525.0. Ah. Oh. 255.25.25.0. And I'm going to do 10.0.0.0.1, like that. Sweet, done. All right, so that should be all okay for our translation to all these servers. We've got 1, 2, 3, 4, 5 servers. 16 is our IP address increment, so none of those are mask. Got /28. So we're all good down there. At least that's what I think we are anyway. So I need to check our inside and outside IP addresses just to make sure that we are indeed fine. Also our inside. Do we have our inside configured? We do, and that's on 10.0.0.1. IP NAT outside is configured for our 17. So that should be fine. There should be nothing wrong with that. That should be reachable now. Now it's just a case of plumbing it into the main network for our NAT, and we should be fine on that premise. That's something that we'll do tomorrow, I think. So that way we can see if it works, which is going to be good. And I need to change some of these fibers as well, because those fibers are not that great. Haven't had time to really do the virtual redundancy protocol because we just haven't had time. But anyway, we'll have a look at that tomorrow. That's something that's on my mind for tomorrow. And yeah, I hope this has been helpful. And yeah, I hope you learned something today. We will go through to see whether or not our NATs are configured correctly tomorrow, I think, as well. That's going to take a bit more time. I've got a bit more time tomorrow. We'll do about, a good 2 to 3 hour stream. And then that will give us some more information as to, how do we tackle this massive, massive lab in preparation for the CCNP, and also as a means to close out an 8-year cycle for me for the CCNA. So I hope you've enjoyed it. I hope it's been useful. I hope you can go out, learn. Have a look at the first video as well on how we did the P2P OSPF, how we got around some of these inter-area problems that you would see in the CCNP, for example. And yeah, have fun, take it in your stride. It's been a bit of a short one today, but anyway, have a look. Hope it works, and I'll see you in the next one.